Dear students, in our last classes we learned calculation of CVR, GFR, ASFR and TFR. Now we calculate TFR for two different locations. When two different locations of population, female population of childbearing age and the number of live births are given. And when the population differs for two locations, so we cannot compare with the help of CVR, GFR. So we calculate TFR and we compare them both. So here given city A and city B, two locations and their female population live births are given. Let us calculate first ASFR for both locations and TFR and comparison of both. So first we need to draw two more columns here. For first ASFR for city A and ASFR for city B. To calculate ASFR, the formula ASFR is equal to number of live births, number of live births in a specific or specified age group in the year divided by total number of women of the particular age group in the year into 1000. So let us show one calculation of ASFR at least. So I calculate ASFR for age group 15 to 19 for city A here. So for city A, live births are 60 for age group 15 to 19 and total females of 15 to 19 age group are 1000 into 1000. So ASFR for location A for age group 15 to 19 is 30 get cancelled, 60 divided by 1 is 60. So I write here 60. And for calculation of ASFR for location B 15 to 19. So here female live births are 1000 divided by population is 50,000 into 1000. So 30 get cancelled. So 1000 divided by 50, that is here 20. So ASFR for CDP for age group 15 to 19 is 20. Now let us calculate the remaining directly and let me write them directly here. So for age group 20 to 24, live births are 200 and population is 2500. So 200 divided by 2500 into 1000, that comes to 80. And third 390 live births divided by 3000 into 1000. So that is 130. And the next 110 divided by 2200 into 1000, that is 50. And next 50 divided by 800 into 1000, that comes to 62.5. And next 10 divided by 400 into 1000. So 10 divided by 400 into 1000 is 25. And last 0. Live births are 0. So 0 divided by 200 into 1000 is 0 itself. So ASFR for age group, so for 45 to 49 is 0 for location A. Then for city B, remaining ASFRs, so live births are 7000 divided by 60,000 into 1000. So 7000 divided by 1000 into 60,000 into 1000 is 116.666. So that rounded up figure is 116.67. So next second 8,000 laborers divided by 45,000 females into 1000. That comes to 177.78. Next 5,000 divided by 40,000 into 1000. That is 125.0. And next 900 divided by 30,000 into 1000. That is 30.00. And next 100 divided by 25,000 into 1000. That comes to 4.00. And last one 50 divided by 20,000 into 1000. That is 2.5. Now we need total for these two columns. Total ASFR of city A and total of city B. Now, so ASFR 60 plus 80, 140 plus 130, 270 plus 50, 320 plus 62. So total becomes 407.50. And for city B, total of ASF for column is 475.95. 475.95. Now formula for TFR. TFR is equal to 5 into summation of quinquennial ASFR. So quinquennial ASFR we have calculated here and also made the total. So now TFR for location A. TFR for city A is equal to 5 into 407.50. So 5 to 407.50 is 2037. 2037.50. So this is per 1000 users. So if we calculate TFR per woman, TFR per woman is equal to 2037.5 divided by 1000 is equal to 2.0375. Approximately is equal to 2.04. That is per woman 2.04 live births will take place for city A. Now for city B, TFR for city B 5 into total of ASFR is 475.95. So it becomes 475.95. That is 2379.65. So here TFR per woman is equal to 2379.65 divided by 1000 is equal to 2.3795. Approximately is equal to 2.38. That is in the city B, a woman will give birth to 2.38 child approximately. So here when we compare both the location here, location B's TFR is greater than location A's TFR. So it indicates that, it tells that, so location B is more fertile compared to location A, that is city A here. So you write comment here, TFR of city A is less than TFR of city B. Therefore, city B is more fertile. This is how we calculate ASFR when two locations are given, and compare TFR here. And which location has higher the TFR, that location we consider as a more fertile. That indicates here the medical facility or advanced medical facilities and healthy food are available in that location. So, and sometime in the problem they may give directly ASFRs. Instead of giving population and live births, directly they will give ASFR. So there they give fertility per 1000, or they may mention ASFR or births per 1000, like that they may mention. So then directly make the total of ASFR columns, multiply by 5 and get the TFR. Then compare and write the comment for the given problem. So here in this problem, city B's TFR is greater than city A, therefore city B is more fertile here. Dear students, in last classes we learned fertility rates, and fertility rate gives us what is the fertility of the location, how many live births are taking place in particular locations, and we can compare with the other locations. So what is the fertility, which location is more fertile, so those are things we can compare. But when we calculate fertility rates, we cannot say that whether in future population is going to increase or decrease. There is growth of the population, whether there is a growth or not. So just we can say that, so per 1000, last year this much was the population and current year this much. That may vary, but that cannot indicate that in future population is going to increase or decreasing. So to know the growth rate, we calculate next rates, that is for growth rate. So growth rate we can say here, and by another name, that is reproduction rates. So reproduction means here reproductive span of the population. What is reproduction span? So reproduction span is those who give birth to the babies. So only females will give birth to the babies. So when a woman give birth to the baby, if it is a female, a girl baby, then that girl baby is going to give birth in future. When she reach the age of 15, then she will give birth to another baby. And likewise it will go on. If a female gives birth to a male baby is not going to give birth to any person. So here, by considering that TFR which we use to compare with other location, there also it is unable to tell that whether population is going to increase, because it includes both male and female live births also. So to say that whether population is going to increase in future, so we have to calculate reproductive rate, that is by considering female population and female live births. So if female live births are more, then in future population is going to increase. If female population is less, then population is going to decrease. So here, to reproduction rate, we can calculate two different kinds of reproduction rate. First one, gross reproduction rate. Gross reproduction rate. And second one, net reproduction rate. So what is this gross reproduction rate? So gross reproduction is one where the death of a mother before reaching her 49th age, that is because if a mother lives still 49-year age, in between that age she can give birth to few more babies. So if she dies in between, that the production that is babies are not going to born in future. And also a baby, no doubt a female has given birth to a girl baby, but if it is alive till its 15th age, we can consider that that baby will now is capable of giving birth to the future generation. and when she is alive till her 49th year age, then she will give birth. So here, if they died before reaching age 15 and even mother dies before reaching age 49, they are not going to give birth to any. That means population is going to decrease there. So here in gross reproduction rate, death of a mother or death of a baby is not considered. That is, here mortality ratio is not considered. What is mortality ratio? It tells that per 1000 live births or per 1000 population, how many are going to die before reaching certain age. So that may be even individual age, we can say. So a 1 year old baby, whether it is going to reach second year or not. So mortality rate. So here gross reproduction rate, it doesn't consider mortality rate, and where net reproduction rate, here mortality rate is considered. So how many are going to survive, that population is going to taken, and whether population is going to increase or decrease is calculated here. So when it comes to the definition of GRR, so GRR means here the sum of annual WSFR. WSFR means here woman specific fertility rate. As we calculated TFR, calculation of TFR, we calculated ASFR, age specific fertility rate. Here we calculate woman specific fertility rate. That is fertility rate age wise, particularly only we have taken there, we take there female live births or girl live births. So in ASFR we have taken both male live birth and female live birth. In calculation of GRR and NRR, we take only female live birth. So we calculate here what? WSFR, woman specific fertility rate. So here the GRR is sum total of WSFR of entire reproductive span without mortality, without considering the death rate. Okay, and here how do we compare? So after calculating WSFR, we calculate GRR. So what is the formula to calculate GRR? GRR is equal to I into summation 15 to 49 WSFR. So here I is the width of or the age group. What is the age gap taken in the age group? So usually we take here 5-year age gap and total 7 age groups. So usually this I is 5, but we cannot write 5 here because we can calculate WSFR for various age groups also. So in TFR we calculate TFR by considering 5-year width age group of total 7 age group. Here that is not considered as compulsory. So I into summation 15 to 49 WSFRs. So WSFR formula, WSFR is equal to number of female live birth, to a woman of specified age group in a year divided by total number of women in that particular age group in a year into 1000. So in short, if you write it, so WSFR is equal to female births divided by female births to the age of X woman divided by female population of age X into 1000. FBX indicates female births for age X woman, and FBX indicates female population of particular age X here into 1000. And here, as I said, GRR, no mortality rate. And when we calculate NRR considers the mortality rate here. And what is the definition of NRR? So NRR definition is the average number of daughters that would be born to a female if she passed through her lifetime, confirming the age specific fertility and mortality rate of a given year. So for particular year, particular time period, if a newborn baby, if it is a female and it passes through all these mortality conditions, that baby should attain the age of childbearing age, and also it should reach childbearing age, and it should be alive till its 49th year. So it should consider both the fertility rate and also mortality rate. So fertility rate, it should reach childbearing age, and mortality rate, it should be alive in that particular time period. So if it passes through all these conditions, then it is considered as a NRR. Okay, so average number of daughters that would be born to a female if she passes through her lifetime, confirming to the age specific fertility and mortality rate. Age specific fertility and mortality rates. So here the formula to calculate NRR is NRR is equal to R into summation 15 to 19 WSFR. So as we are considering here mortality rate, so WSFR is multiplied with survival ratio. What is the survival ratio? So that is multiplied here to WSFR. That means we are skipping the babies or the mothers who are going to die in that particular year. So WSFR into S. So here also we calculate WSFR. And here when we calculate both GRR and NRR, we convert it to per woman. So here by calculating this, we get per thousand woman, but we convert it to per woman. When we convert it to per woman, the figure may come less than 1 or more than 1 or equal to 1. So our comment is whether population is going to increase or decrease will be said based on per woman GRR or per woman NRR. And when the population GRR or NRR figure is exactly 1, it indicates that the population is going to be stable. It is not going to increase or decrease either. But when the either GRR or NRR is greater than 1, then we say that population is going to increase in future. And again, if the either NRR or GRR is less than 1, then we say population is going to decrease in future. So population is decreasing. NRR is 1, no increase or no decrease, stable population. If NRR is greater than 1, population is increasing, and NRR is less than 1, population is decreasing. Same for GRR. If GRR is 1, stable population, GRR is more than 1, increasing population, and GRR is less than 1, then population is going to decrease. And certain time we calculate both, and the situation may come where GRR is greater than 1 and NRR is less than 1. And before that, I tell you one more thing, that GRR and NRR, when we calculate both ratios here, NRR cannot exceed GRR mathematically, because here it is considering mortality ratio, that is probability of birth and death. Okay, so that means here NRR, as it is skipping the persons how many are going to die in the year, that means here it is NRR is always less than GRR. Suppose in a location there are 1000 persons, 1000 females, and they give birth to suppose 100 females. Then 100 divided by 1000 into 1000 we calculate. So we get 100 as a GRR suppose. And in that, out of that 1000 and 100 babies, suppose 2% are going to die. That means out of 100 babies, 2 are going to die. So 98 babies will be alive. And out of 1000 mothers, 2%, that means 20 mothers are going to die. It means 980 mothers will stay back alive. So that means here the calculation figure is reduced when you calculate NRR compared to GRR. So GRR and NRR, when we calculate both, NRR cannot exceed GRR mathematically. So on this base, the question may come for 2 marks. If GRR is 1.5 and NRR is 1.8, whatever may be the figure, here we have to compare both. If NRR figure is greater than 1, means the given statement is wrong. It may be greater than, both may be greater than 1 or both may be less than 1. Even the question may ask, if NRR is 0.9 and GRR is 0.8. So here again NRR is greater than GRR. So here also we can say the given statement is wrong. If they ask like this, if NRR is 0.9 and GRR is 0.99 or GRR is 1. So here given statement is right. Even NRR is and NRR and GRR both are here less than 1. That indicates population is decreasing. If NRR is 1.2 and GRR is 1.5, so both are greater than 1, so we say population is going to increase. Both cannot be 1. Okay, but the situation may come where GRR is more than 1 and NRR is less than 1. For example, GRR is equal to 1.2 and NRR is equal to 0.9. So in such cases here, writing comment is important. So here which one to consider? So because GRR is telling that population is going to increase, whereas NRR is telling population is going to decrease. So when we calculate both, and if we get such a situation where NRR is less than 1 and GRR is greater than 1, we must write a comment based on NRR because it considers the mortality ratio. So it gives an accurate result. So NRR, based on NRR, we have to write a comment that population is going to decrease in future. So this is all about GRR and NRR theory part. Next we are going to calculate problems on both GRR and NRR. And here when it comes to the exam point of view, GRR or NRR may be asked for 5 marks individually, any one. And for 10 marks both together will be asked, GRR and NRR both together. And from fertility rates, CBR will be asked for 5 marks along with GFR or maybe one ASFR calculation. And for single location, TFR will be asked for 5 marks. And 2 locations, which we calculated in yesterday's class. So 2 locations, TFR for 10 marks may come up to here. So now in our next session we calculate problem to solve GRR and NRR, and we will find growth of the population, whether this population is going to increase or decrease. Let us calculate both the GRR and NRR here. So here is the problem. Compute GRR and NRR for the following data and comment on growth rate. So here age group, 5-year width and total 7 classes are given, and female population, female laborers are given, and survival ratio is given here. So survival ratio is required to calculate NRR, and to calculate both the GRR and NRR we have to calculate first what? WSFR. So what is the formula for to calculate WSFR? So WSFR is equal to, so female births of age group X females and female population of age group X into 1000. So when you write in short here in exam, you have to write what is FBX and what is FPX. Otherwise, write the formula in full. So here, first for age group, WSFR for age group 15 to 19. So 15 to 19 female laborers are 50 divided by female population is 3000 into 1000. So here WSFR for first age group 15 to 19 is 16.66. 16.66. That I write here in the table WSFR. So that is 16.66. Like that for remaining the age groups WSFR. So for second age group 20 to 24 400 laborers and 2500 female, and in 2000 if you do, so 400 divided by 2500 into 1000 we get 160.00. And third age group 25 to 29 300 female laborers and 2200 females. So if you calculate WSFR we get 136.66. And third fourth age group 30 to 34 100 divided by 2000 into 1000 we get 50.00. And next age group 35 to 39, so 60 live birth and 1800 females we get 33.33. And next 40 to 44 30 female laborers and total 1500 females, here we get 20.00 WSFR. And last age group 45 to 49 10 female laborers and 1200 females, so we get 8.33 WSFR. Now next column we need to calculate is WSFR into S, that is survival ratio column, yes, into WSFR column. So 0.9 into 16.66 we get 40.99. And next 0.9 into 160, that is 144.00. And next 0.8 into 136.66 109.08. And next 0.8 into 50 40. 0.8 into 33.33 26.66. And next 0.8 into 20 16. And 0.7 into 8.33 we get 5.83. Now make the total of both the WSFR column and WSFR into S column. So WSFR column comes to 424.98 and WSFR into S column total is 356.56. Now the formula to calculate GRR. So GRR is equal to I into summation WSFR. So I is here, width of is 5 years here. So 15 to 19 means 5 age group are taken here, 5 ages. So I is 5. So GRR is equal to 5 into summation WSFR, that is 424.98. So GRR is equal to 5 into 424.98, we get 2124.9. So this is per thousand, GRR per thousand. We need to calculate GRR per woman. Per woman means here GRR per woman is equal to GRR divided by 1000. That is 2124.9 divided by 1000. That is 2.1249. So GRR per woman is 2.12. GRR per woman is 2.1249. Okay, now GRR we have calculated, and GRR, if we have calculated only GRR, then here GRR figure per woman is greater than 1, that is 2.1249. It is greater than 1, so it tells that population is going to increase in future. Now let us calculate NRR and what it tells, whether we get NRR greater than 1 or less than 1, what it tells. So formula of calculating NRR is again I into summation WSFR into S into survival ratio, that already we have calculated. So total of WSFR into S column is 356.56. So that means 5 into 356.56. So NRR per 1000 women we get 5 into 356.56 is 1782.8. 1728.8. This is per 1000 again. So per woman, NRR per woman is equal to 1728.8 divided by 1000, that we get 1.7288. 1.7288. Okay. Now here what it tells, NRR per woman is equal to 1.7288. So here 1.788, it is again greater than 1. So GRR is also greater than 1 and NRR is also greater than 1. So the conclusion here is, based on both GRR and NRR, is the population is going to increase here. So write the comment here, as GRR and NRR are greater than 1, the population is increasing. Population is increasing. Suppose if you would have got both less than 1, if GRR as well as NRR both less than 1, then the comment would be the population is going to decrease, or population is decreasing. And if the GRR is greater than 1 and NRR is less than 1, then the comment is, based on NRR, population is going to decrease. So in our next class we solve one more problem on GRR and NRR both. So where we get GRR greater than 1 and NRR less than 1. And remember one thing here, no need to calculate both until they ask. So if in question paper the question comes for 5 marks, they ask either GRR or NRR. If it comes for 10 marks, they ask both GRR and NRR.